Hello everyone, welcome to my YouTube channel, Ma'am Balot's Math Tutorial. In this vlog, we will all be discussing mathematics topics, especially for my students in grade 10. Today, we will be discussing all about patterns. When we say patterns, what would be the word that comes first in our mind? Maybe we can have some arrangement, format, a design, or shall I say a sequence. So in this topic, we will be focusing all about sequence. Our first activity is entitled Next in Line. In your elementary years, you have probably met this kind of activity, which is just very simple because it is just predicting the next shape from the pattern given. So in here, we have a rectangle and oval, then followed by two triangles. So a rectangle and oval, a triangle, so therefore the next shape must be a triangle. In number 2, observe that in the first figure, we have two squares at the base and then one square at the upper part. In the second figure, we have already three squares at the base and then it's the upper part is the first figure. Then the next figure, we have already four squares at the base and then its upper part is all the squares in the second figure. So therefore, the next figure must be, we have 5 squares at the base and then its upper part is the figure in the third figure. Okay, number 3. Suppose we have the numbers already. So we have 0, 4, 8, 12, 16, and 20. So observe that from 0 to 4, we need to add 4. Then the next one, we also need to add 4. And so on and so forth. So therefore, for the next number, we need to add another 4, which is now equal to 24. In number 4, we have here a negative 7. We have to add a negative 7 or subtract by 7. So 19 minus 7 is equal to 12. Subtract another 7, it is equal to 5. Minus 7, it would be negative 2, and so on. So therefore, if we add another negative 7, so the result must be negative 23. In number 5, we have here 2, 6, 18, 54, 162, and blank. So as you observe, from 2 to 6, and then from 6 to 18, we need to multiply by 3. So 2 times 3 is equal to 6. 6 times 3 is equals to 18. Multiply another 3, so we have 54, and so on. So therefore, to get the next number, we will multiply 162 by 3, so we get 486. In number 6, from 320, you have 160 and then 80. So observe that we have divided it by 2. So 320 divided by 2 is 160. Divide again by 2, you have 80. Divide by 2 is 40. You have 20. And then 20 divided by 2, so the next number must be 10. Okay, so we will now focus on sequences. A sequence is a function whose domain is the finite set 1, 2, 3 up to n, or the infinite set 1, 2, 3, and so on. So for example, we have n 1 to 5, and a sub n would be 0, 4, 8, 12, and 16. So in this example, as you can see, if n is equal to 1, so the result output would be 0. If n is to 2, so the output is 4. If n is 3, we have 8. If 4, we have 12, and then 5, we have 16. Let's have example number 1. So we have here n from 1 up to 5, and then a sub n, 0, 4, 8, 12, and 16. So observe that these 0, 4, 8, 12, and 16 are what we call terms in our sequence. So since we have 5 terms, so this example is a finite sequence. And the terms are represented by a sub n. So 0 is represented by a sub 1, or what we call the first term. 4 is a sub 2, or the second term. 8 is the third term. 12 is the fourth term, and 16 is the fifth term. In example 2, observe that we have an infinite number of n. So, therefore, this is an example of an infinite sequence. But still, we can address the different terms as a sub 1, a sub 2, a sub 3, and so on. In example 2, observe that the values or the terms from a sub n can be generated from this pattern. A sub n is equals to 3n plus 1. Because if n is equal to 1, so we will try to substitute 1 to n. So that would be a sub 1 is equal to 3 times 1 plus 1. So 3 times 1 is equal to 3. And then 3 plus 1 is equal to 4. So that is why our first term is 4. If n is equal to 2, so we will be referring to the second term. So that would be a sub 2 is equal to 3 times 2 plus 1. So 3 times 2 is 6. And then 6 plus 1 is 7. And that would be our second term. The next example, we have this one. Find the first 5 terms of the sequence given its nth term as a sub n is equal to 13 minus 4n. So in this pattern, we will be finding a sub 1 up to a sub 5. So, if n is equal to 1, we will substitute 1 to n. So that would be a sub 1 is equal to 13 minus 4 times 1. So 4 times 1 is equal to 4. And then if we subtract 13 minus 4, so we have a 9. Then solving for the second term, we have n is equal to 2. So we have 13 minus 4 times 2. So 4 times 2 is 8. And then 13 minus 8 is equal to 5. So therefore, our second term is 5. The third term now is if n is equal to 3. So we have now 13 minus 4 times 3. So 4 times 3 is equal to 12. And if we subtract 13 minus 12, we get a 1. So therefore, our third term is 1. The fourth term is if n is equal to 4. So you have 13 minus 4 times 4. So 4 times 4 is 16. And then 13 minus 16 is negative 3. Negative 3 now is our fourth term. And lastly, if n is equal to 5, so we have 13 minus 4 times 5. So 4 times 5 is equal to 20. And then 13 minus 20 is negative 7. So our fifth term is negative 7. So thus, the first 5 terms from the nth term a sub n equal to 13 minus 4n are 9, 5, 1, negative 3, and negative 7. How about if you are asked to find the nth term of a sequence given its terms? So we'll have now a vice versa process. So we have example 4. Find the general term of the sequence 5, 8, 11, 14, 17, and so on. So from these terms, we can have this table from our finite sequence. So representing the different a sub n's. So from this, we can get the difference of the terms, which is positive 3, or we just add 3 from 5 to 8. Okay, 8 to 11, again, we have to add 3. 11 to 14 plus 3, and then plus 3, you have 17. So observe that the difference are constant, which means that this implies a linear relationship. Using the standard form of the linear equation, we can have a sub n is equal to an plus b, where n is our linear variable and a and b are real numbers. So using the pairs of numbers from the table given, so we can have if n is equal to 1, a sub 1 would be 5. If n is equal to 2, a sub 2 is equal to 8, and so on. So from this, we can solve the system of linear equations with two unknowns by using two pairs of numbers from the table. So say we will use n is equal to 1 and n is equal to 2. So from this, we can create new equations by substituting n in our standard form. A sub n is equal to a n plus b. So we will substitute n is equal to 1 first. So we have now a sub 1 is equal to 5. So we have there 5 is equal to a times 1 since our n is 1, and then plus b. 8 times 1 is equal to a. So therefore, our first equation would be 5 is equals to a plus b. Then we will use n is equal to 2 to get another equation. So we have now a sub 2 is equal to 8. So we have 8 is equal to a times 2 since n is equal to 2, then plus b. 8 times 2 is equal to 2a. So therefore, our second equation would be 8 is equal to 2a plus b. So we will now use these two equations to solve for the values of a and b. So we will use the elimination method by the two equations. A plus b is equal to 5 and 2a plus b is equal to 8. Observe that we have flipped the equations such that the constants would be at the right side for your convenience. So observe here that b has the same numerical coefficient. So therefore, we will subtract the two equations to eliminate the variable b. So subtracting now, we can cancel out b, and then a minus 2a would be equal to negative a, and then 5 minus 8 is equal to negative 3. Therefore, since we need to get the value of a, so we will divide both sides of the equation by negative 1. So we get now a is equal to 3. So since we have already a value of a, we will now find the value of b by using a is equal to 3 and equation 1, which is a plus b is equal to 5. So we will just substitute 3 to a, so therefore we can have 3 plus b is equal to 5. So to solve for b, we will use the addition property of equality, so therefore we will add negative 3 on both sides such that b will be the one left on the left side. So we have now b is equal to 5 minus 3, which is 2. So therefore, we have the value of b, which is 2. So we will now substitute the values of a and b into our equation. A sub n is equal to a n plus b. So we have now a sub n is equal to 3n plus 2. So this is now the general term of the sequence given. Another example is, find the general term of the sequence negative 1, 2, 9, 20, 35, and so on. So again, we need to construct this table and determine the differences of the different terms. So from this, we can have the difference from the first and second term is 3, then the next is 7, then we have 11 and 15. So observe that their differences are not constant. Thus, it is not implies a linear relationship. So if we get the second difference, we have now 4, 4, and 4. So this time it is already a constant, which implies that the relationship is quadratic. So if we recall the general form of the quadratic equation, so we can have a sub n is equal to a n squared plus b n plus c. So our n is the quadratic variable, and a, b, and c are real numbers. So from this, we can use another pairs of numbers from the table, which are the following. If n is equal to 1, a sub 1 would be negative 1. If n is equal to 2, a sub 2 is equal to 2, and so on. So since we have three variables, which are a, b, and c, so we need three pairs of numbers. We will now solve the system of linear equations with three unknowns using these pairs of numbers from the table. So since we have three unknowns, so we need three equations to solve for the unknowns. So we will start when n is equal to 1 and a sub 1 is equal to negative 1. So we will substitute the value of n into a sub n is equal to a n squared plus bn plus c. So if n is equal to 1, so a sub 1 is equal to negative 1, which is colored there in green. So which is equal to a times 1 squared, since n is equal to 1. Then plus b times 1, which is also our n. Then plus c. So from there we have 1 squared is equal to 1. Then b times 1 is equal to b. And then a times 1 is equal to a. So therefore, our first equation is negative 1 is equal to a plus b plus c. For n is equal to 2, our a sub 2 is equal to 2 also. So we have 2 is equal to a times 2 squared plus b times 2 plus c. So 2 squared is equal to 4. And then b times 2 is equal now to 2b. So we have now a times 4, which is equal to 4a. Therefore, our second equation would be 2 equals 4a plus 2b plus c. So the last equation is for n is equal to 3. And a sub 3 is equal to 9. So we have here 9 is equal to a times 3 squared plus b times 3 plus c. 3 squared is equal to 9. So we have there a times 9. And then b times 3 is equal to 3b. Then a times 9 is equal to 9a. So therefore, our equation number 3 is 9 is equal to 9a plus 3b plus c. We are now ready to use the elimination method for equations 1 and 2. Observe that the numerical coefficients of c are the same. So we can subtract the two equations to eliminate c. So we have a minus 4a is equal to negative 3a. b minus 2b is equal to negative b. And negative 1 minus 2 is equal to negative 3. This now becomes our equation 4. So we will use again equation 2 and 3 to obtain another equation. So since we have already eliminated c for equations 1 and 2, therefore we will again eliminate c in this pair of equation such that we can have the same variables left. So from this, we will again subtract the two equations to eliminate c. So we have now 4a minus 9a is equal to negative 5a. 2b minus 3b is equal to negative b. And 2 minus 9 is equal to negative 7. This now becomes our equation 5. So observe that we have already two variables left. So again, we can pair up equations 4 and 5 to solve for the values of a and b. So we will use the elimination method again for equation 4 and 5. So from here, we also observe that b has the same numerical coefficient. So we will again subtract the two equations to eliminate b. So we have now negative 3a minus negative 5a is equal now to positive 2a, which is equal to negative 3 minus negative 7 is equal to positive 4. So from this, we can now solve the value of a. So since we have a numerical coefficient of 2, so we will divide both sides of the equation by 2. So we get now 2a divided by 2 is equal to a, which is equal to 4 divided by 2 is equal to 2. So therefore, the value of a is 2. So since we have already a value of a, we can now compute for the value of b. So we will solve b using a is equal to 2 and equation number 4, which is negative 3a minus b equals negative 3. So we substitute a equal to 2, so we have negative 3 times 2 minus b equals negative 3. So multiplying negative 3 and 2, we have negative 6 minus b is equal to 3. So to solve for b, we need to add 6 on both sides. So we have now negative 6 minus b plus 6 equal to negative 3 plus 6. So on the left side, the constant becomes 0. So what's left is negative b is equal to negative 3 plus 6 is equal to positive 3. So since we still have a negative 1 coefficient for b, so therefore we will divide that whole equation by negative 1. So we got b is equal to 3. So we have now the values of a and b. So what's left is c. So solving now for c, we can use the values obtained of a and b and the equation 1, which is a plus b plus c equals negative 1. So substitute a and b, we have now 2 minus 3 plus c equals negative 1. 2 minus 3 is equal to negative 1. Then plus c equals negative 1. So to solve for c, we need to add 1 on both sides. So we have now c is equal to 0. So we will now substitute the values of a, b, and c to our general form an squared plus bn plus c. So that becomes now a sub n is equal to 2n squared minus 3n plus 0. So since 0 don't have some value, so we can simplify our equation into a sub n is equal to 2n squared minus 3. So this is now the general term of the sequence given. Our last example is find the general term of the sequence 2, 4, 8, 16, 32, and so on. So from these terms, we can have this table and the differences of the different terms. Observe that the first difference are not constant, which implies that this is not a linear function. If we compute for the second difference, still it is not constant, so therefore it is not also a quadratic function. And if we get the third difference and so on, observe that there is no chance that their differences becomes constant, which implies that these terms follows an exponential function. Since exponential function is not yet discussed in grade 10, so we will use another strategy to solve this sequence. We will now use this process. From the table here, we can see that a sub 1 is equal to 2, which is equal to 2 to the first power. A sub 2 is equal to 4, which is equal to 2 squared. And then a sub 3 is equal to 8, which is equal to 2 cubed. A sub 4 is equal to 16, which is 2 to the 4th. And a sub 5 is equal to 32, which is 2 to the 5th. Observe that the exponents are increasing as well as the value of n. So therefore, to get the value of a sub n, we have now a sub n is equal to 2 to the n. So that is now the general term of the given sequence. Now you can try to solve on your own using your mode choice. Thank you so much for watching. Till our next video, which we will be discussing all about arithmetic sequence. Please don't forget to like and subscribe. Thank you so much. At your service, Ma'am Balot. Bye!